Welcome to the final lesson on factoring. Before we get into actually working with quadratic equations in Unit 8 and solving them. So we need to learn how to factor special products and factor polynomials down completely before we can move on to that step. So I'm going to show you how to do that today. So let's take a look at some special patterns and then we'll move on to how to factor a polynomial completely. So some of these special products are things that we looked on when we were multiplying. We found the difference of two squares, and this can be solved anyway. So let's say that we have x squared minus 64. We want to break that down. So if I don't know what I'm doing, I can think of that as x squared plus 0x, because there's no x term, there's no b term, minus 64. Now there's no value of a, so I can just set up my diamond and say it's negative 64 and sum of 0. Well, if it's got a sum of 0, they've got to be opposites. So 8 and negative 8 multiply to give me negative 64, and it's a sum of 0. So it's x plus 8, x minus 8. So if you remember from our work with multiplying, this is that sum and difference pattern. X squared minus 8x plus 8x minus 64. So remember, when we have these opposites here, plus 8 and negative 8, those middle terms cancel each other out and we're left with x squared minus 64. So that's where we can find that special pattern, and if you realize that, you can break it down right away and know that the only way to multiply to get x squared is x times x. If I'm canceling out the middle term, these have to be opposites. So square root of 64 is 8, so it's positive 8 and negative 8. And that's where that pattern comes into play that you see at the bottom of your notes there. Next one, why don't you try that one? Well, we'll do that one together since it's a little bit different, but you can definitely try it on your own. If I were to take a look at that one, you might think, well, I have 16x squared plus 0x and z minus 144z squared. So I got a value for a, so I would multiply that. And 16 times negative 144, I need my calculator, just a second. All right, I'm back. 16 times 144 is 2304. So here's where the AC method might give us some problems here, because 2304 is a pretty big number. But taking what we know about this, we can still figure it out. We're still pretty intelligent people. So 2304 is our product and a sum of 0. And I know if it's a sum of 0, it's got to be its opposite. It's got to be the same number. So really it's a square root. So I take the square root of 234 on my calculator, or I do it in my head. You can't tell because you can't see me. And it's 48. So 48 and negative 48. So I would have x plus 48, and since it's z squared, I got to use z in there, and x minus 48z. But since I used the 16, I got to put it back in using the AC method, and then I got to divide it out. Well, 16 and 48, let's see, what can I divide those? I can divide those both by 4. So I'm left with 4x plus 12z and 4x minus 12z. So here's where knowing my special products will help me out. If I can recognize that special product right away, that it's a difference of two squares, perfect square, perfect square. If you see perfect square, difference of two perfect squares, save yourself some time and think, well, how do I get 16x squared? That's 4x times 4x. And how do I get 144z squared? It's 12z times 12z. And since I'm eliminating the middle term, it's a sum and difference pattern. So recognizing that common occurrence, this happens all the time when we have a difference of two perfect squares. So if you can recognize perfect squares, that's why it's important to know those, you'll save yourself a little bit of time. Next, we'll talk about what's known as the perfect square trinomial. It's known as a perfect square trinomial because it's a trinomial, and I've got perfect squares in each position. So if I don't know the pattern, I can just start off by making my diamond. You can solve all these by using the diamond, but there's always quicker methods. 64 is my product, 16 is my sum. Well, I end up with 8 and 8. So x plus 8 and x plus 8. Hey, look at that. It's the same thing. So it's really x plus 8 squared. If you remember from your multiplication, when we're multiplying the same thing, I double that middle term and add it up. X times 8 is 8x plus times 2 is 16x. And I square both the beginning and the end term. That was that pattern. So if you can figure that out, you can apply that. So here, if I see perfect square, perfect square, perfect square, hopefully I've learned my perfect squares. Well, how do I get 4x squared? Well, that's 2x. How do I get 81? Perfect square of 9. Since I need to get a sum of negative 36, I subtract. 2x minus 9 times 2x minus 9. Okay, keep in mind I could have done that using the AC method, but if I could pick out my perfect square trinomial, it's going to save me a lot of time. So take a look at those examples down there and see if those make sense. You can ask about that in class. Next, let's talk about how to factor completely. When we factor completely, we're talking about factoring polynomial until it's a product of two or more polynomials with integer coefficients. So we're breaking it down as far as we possibly can. So if we're looking at this is the first steps in factoring it out. So I've got two terms. Each of these terms is partially factored. Well, what do I have in common between these terms? Well, they both have an x plus 2. So if I divide both of these by x plus 2 and divide that out, I'm really pulling that x plus 2 out of those. And what am I left with? 3x plus 2. So in this case, we're looking to factor out a binomial, a common binomial, and rewrite this expression. And that's how we factor it. Notice this term and this term do not have a common binomial, but y minus 4 and 4 minus y look similar. So if I can switch that order around and really make it negative y plus 4, it still doesn't look the same. So I guess I haven't accomplished much. But I can make it look the same. And the way I can do that is I can factor out a negative 1. So take a negative 1 out of here. And that gives me y squared, y minus 4. And since I factor out a negative 1, this becomes negative 5. When I divide negative y by negative 1, it's positive y. When I divide 4 by negative 1, it's negative 4. Now I have this common binomial, which I can factor out. Factor that out and put it at the beginning, y minus 4. So when I divide out a y minus 4, I'm left with y squared at the beginning. When I factor out the y minus 4, I'm left with minus 5 at the end there. And at this point, I need to factor completely, so I've got a y. Can I break down the y squared any further? Well, I've only got two terms. If it's two terms, it's got to be the difference of two perfect squares. Y squared is a perfect square, but 5 is not. It won't give me what I need. So at this point, I would be done factoring that one down. Let's do some practice with that. When we have four terms, we can factor it by grouping. and do what we did in those first steps in the previous slide. So I'm going to group these two together. I'm going to group those into two terms. So what can I take out of this first grouping? Well, what do they have in common? X squared. So I'll rewrite it as x squared, and if I pull the x squared out of there, divide it out, factor it out, I'm left with x and positive 7. Look what I have in common the next one. They can both be divisible by 5. So I'll pull out a positive 5. What am I left with? X plus 7. So now that's what we did in the previous slide. What does this term have in common with this term? I can divide them both by x plus 7. So take that x plus 7 and divide it out. What am I left with? X squared plus 5. And can I factor this down any further? This one is as far as it can go. X squared, possible. It has to be a difference of two perfect squares, and it's a sum. So I can't factor that down any further. I would be done with that one. Here we got multiple variables, but I got 4 terms. Anytime I got 4 terms, try to factor by putting it into groups. Y squared plus y, I can factor out a y, leave me with y plus 1. Yx and x, I can factor out a positive x. Leave me also with y plus 1. When we do the factoring method, we should find a common binomial that we can pull out. So I can factor out a y plus 1. Okay, so I pull out that y plus 1, and I'm left with y plus x. And our variables are all first degree, so that's as far as we can go. All right, so let's put all of our factoring skills to work. Some different things to keep in mind. Look for a GCF always. Okay, always look for that GCF because that'll make your life easier in multiplying things down if we can take out and shrink the numbers down. So once you find that GCF, if you can take it out, if it's 3 terms, you can make the diamond or use the AC method. If it's 2 terms, you can look for a difference of perfect squares. 4 terms, you can look to group it. So you see a kind of a summary of those. Factor out the GCF if you can. So 3x squared plus 6x, I can pull a 3x out, leave it x plus 2, and then I'm done with that one. If it's 3 terms, here I could use the AC method or set up my diamond with this one. Next thing to keep in mind is if it's 2 terms, I want to look for that. For instance, if it were 2 terms, if we had x squared minus 9, this is a 2-term one, we could break into x plus 3, x minus 3. And if it's 4 terms, we have 4 terms here, now we would use the grouping method. So let's put all that together here and let's work through these examples. I'm going to show the examples worked out, but I'll give you time to work them on your own. Give it a chance to try it out. So pause the video, start it once you are ready to see the worked out solutions. Okay, so the first one was 3 terms. I looked for a GCF, there isn't one. So 3 terms, I made my diamond. Product of -1, sum of 2. Found my 2 values of 2 and -1. So n plus 2, n minus 1. The second one, where should I put myself? Here we go. So first thing I look for is GCF. I can divide them all by 4 and by x. So I divided 4x out of there first. Left me with x squared minus 11x plus 24. Left me with 3 terms inside. So leading coefficient is 1, so I made my diamond of 24 and -11. Gives me my 2 terms of -8 and -3. So x minus 8, x minus 3, and then the 4x that I still had factored out at the beginning. I keep that out there. Number 3, look for my GCF. First thing you should always look for, divide both these by 2x squared. And then that left me with 25x squared minus 1. If it's 2 terms, I look to see if it's a difference of perfect squares. 25x squared is a perfect squared, so is 1. So I break it into 5x times 5x, 1 times 1, sum and difference pattern. And I keep that 2x squared out there. All right, so try these last two again, and I'll show you the worked out example when you're ready. Pause the video, start it again. All right, so the first thing I look at with the first one is there GCF? There's nothing in common with all of them. There's x's with the first three terms, but not the last term. So I can't divide anything out. So it's four terms, so I group it. And as I group it, I see x cubed and x squared. I can pull out an x squared. I'm left with x plus 4. Next, I have negative 25x and negative 100. So I know this term needs to match up with this one. So since this one's a positive x, I'm going to divide out a negative 25, not just a positive 25. And that'll leave me with x plus 4 because negative 100 divided by negative 25 is positive 4. So keep in mind, if you would have divided out positive 25, maybe that's a mistake that you made, I would have negative x minus 4. And these wouldn't match up. So then you could just divide out the negative because these need to match up. So when I divide out x plus 4, I'm left with x squared minus 25. Then know that I'm not done. I need to factor completely. If I have a squared here, I need to look if I can keep going. This is a single degree, so this part's done. But this is two terms. Is it a difference of perfect squares? Perfect square, perfect square. Yes, it is. So we break that into its sum and difference pattern. X plus 5, x minus 5. And we just keep that x plus 4 there. Next one, look for the GCF. 80 and 45 are both divisible by 5. Z to the 8th, z to the 6th, the z to the 6th. Leaves us with 16z squared minus 9. This has a degree greater than 1, so it's possible I could break it down further. Is it a difference of perfect squares since it's two terms? Yes, it is. Square root of 16z squared is 4z, square root of 9 is 3. Follow that sum and difference pattern. So we've looked how to use all of our factoring skills, factoring everything down completely. Just remember those steps. Look for the GCF. Is it three terms? Set up the diamond or the AC method. Is it two terms? Look for a difference of perfect squares. Is it four terms? I need to group it. So work your way through those examples, and I'll be available in class if you need help. So we'll see you then.